Hey guys, welcome back to my channel. Today we're going to do paper 2 of AQA Level 2 Further Maths. We're going to discuss all of the questions that came in June 2025 paper and see what was the trend, whether the paper was difficult this time. So let's start with the questions. So the first question says that the fifth term in sequence A is also a term in sequence B. Work out the position of the term in sequence B. So first, let's find what the fifth term is in sequence A. We'll substitute n equals to 5 in the nth term of A. N equals to 5. So 6 times 5 over 7 times 5 plus 25. That's 30 over 35 plus 25, which is 30 over 60, and that's 1 over 2. Now, this is also a term in sequence B, but we don't know what the position is. So we put the nth term equal to this to find the value of n now. So 1 over 2 equals to 20 over n plus 4. N plus 4 equals to 20 times 2. Cross multiply. N plus 4 equals to 40. N equals to 40 minus 4, and that's 36. So this term is the 36th term for sequence B. That's your answer. Next question says that C and E are points of the circle with the equation x squared plus y squared equals to 144. CD is a straight line. OD is to DE is 3:1. OD is to DE is 5:1. Work out the shaded area. Give your answer as a decimal. So we have the equation of the circle, which is x squared plus y squared equals to 144. This means that your radius is 12 because 144 is 12 square and square root of 12 square is 12. So radius is 12, which means this entire distance from O to E is 12. Why? Because our origin is the center and E is on the circumference, which means OE is the radius. Now OD is to D is 5:1, which means OD is going to be 5 over 6 times 12, which is 10, and DE is going to be 2. We have to work out the shaded area. So what we can do is, can highlight the coordinates first. So this is 12 over here, and this would be negative 12. Why negative 12? Because the radius is the same from the origin. So if OE is 12, this point over here is going to be negative 12. This is also going to be positive 12, and this is going to be negative 12. Now, for the shaded area, what we can do is, if we look at this, we have a sector OCE, and then we have this triangle OCD. If we subtract the area of both of these, we can get the area of the shaded region. So area of sector is theta over 360 times pi r squared. Theta is 90 because it's a 90-degree. 90 over 360 times pi times r squared. R is 12. So that is going to give us 113.097. Now, area of triangle is going to be 1 over 2 times the base, which is OD, that's 10, times the height, which is 12. That's going to give us 60. So shaded area is going to be the difference of 113.097 minus 60, which is going to give us 53.097. Question 3 says that the equation of a straight line is 2ax plus y equals 25, where a is a constant. The line passes through the point 3, 1. Work out the value of the gradient of the line. So what you will do is you will substitute the point 3, 1 into the equation and then find the value of a, and then using that we'll figure out the gradient of the line. So the equation is 2a times 3, which is the value of x, plus 1, which is the value of y, equals to 25. 6a equals to 25 minus 1, 24. A equals to 24 divided by 6, which is 4. So if you substitute this back into the equation, 2 times 4x plus y equals to 25. 8x plus y equals to 25. Put this in slope-intercept form by making y the subject. So y equals to negative 8x plus 25. So your gradient is negative 8. Because gradient is always multiplied with the x. Question 4 says n is greater than or equal to negative 5 and less than or equal to 5. Work out the range of values of n square. So what we will do is, we'll write the inequality first. Since they want the values of n square, we will square everything in this inequality. So that's going to be 25 n square and then again 25. It says work out the range of possible values of n square. Now what you need to realize is 25 to 25 isn't just 25. Negative 4 square is 16. Negative 3 square is 9. Negative 2 square is 4. Negative 1 square is 1. 0 square is 0. Then again 1 square 1. 2 square 4. 3 square 9. 4 square 16. And 5 square 25. So these are all of the square numbers that satisfy this inequality. We need to work out the range. So obviously the smallest value is 0. So n square is greater than or equal to 0, but less than or equal to 25. This would be your answer. Please do not just write less than or equal to 25 because our lowest value is 0. It's not like negative infinity. So n square is greater than or equal to 0, but less than or equal to 25. Question 5 says the equation of a curve is y equals to x to the power of 5 plus p x to the power of 4, where p is a constant. When x equals to negative 1, the gradient of the curve is negative 3. Work out the value of p. So for this, we will differentiate the equation first. Dy by dx equals to, bring the power down, and subtract 1 from the power. So 5x to the power of 4 plus, again bring the power down, 4p times x to the power of 3. So once we've differentiated it, we know that the gradient at x equals to negative 1 is negative 3. So you put dy by dx equal to negative 3 and replace x with negative 1. So 5 times negative 1 to the power of 4 plus 4p times negative 1 cubed. So that's going to be negative 3 equals to 5 minus 4p. Negative 3 minus 5 equals to negative 4p. That's negative 8 equals to negative 4p. And negative 8 divided by negative 4 equals to p, which is 2. So that's your answer. Next question says that C is a point on the straight line AB. AC is to CB is 3 is to 2. Work out the equation of the straight line passing through O and C. So basically, we need to find the equation of this line. So we have the coordinates of A and we have the coordinates of B. We should find the coordinates of C. What we can do is we can use this ratio to figure out the coordinates of C. We know that if we draw a line over here like this, and if we draw another one like this. So the coordinates of C are x and y. This distance is going to be x plus 2.5 because this is a coordinate of negative 2.5 over here. So this is 2.5 and this is x. This all is 20. So this is going to be 20 minus x. Once again, let me draw the arrows. This all is 20. This all is 2.5. And this is x. So this distance is x plus 2.5 and this distance is 20 minus x. Now for the vertical distance, This distance is going to be y minus 1.5, and this distance is going to be nine minus y. So now let's create equations using these values. We know that AC is to CB is 3 is to 2. So AC is going to be x plus 2.5 over 20 minus x is equal to 3 over 2. We're comparing the horizontal distances first. So AC horizontal is x plus 2.5 and CB horizontal is 20 minus x. So x plus 2.5 over 20 minus x, same as 3 over 2. Similarly, now for the vertical distances, AC is y minus 1.5 over 9 minus y equals to 3 over 2. Now we solve these two equations separately to find the value of x and y. Cross multiply. 2x plus 5 equals to 60 minus 3x. 2x plus 3x equals to 60 minus 5. 5x equals to 55. X is 11. Cross multiply over here now. 2y minus 3 equals to 27 minus 3y. 2y plus 3y equals to 27 plus 3. 5y equals to 30. Y is 6. So coordinates of C are 11 and 6. Now to find the gradient for OC, 6 minus 0 over 11 minus 0, that's 6 over 11. And the y-intercept is 0. So y equals to 6 over 11x is your equation, and that's your answer. Question 7, part A says 2 to the power of 5a plus 1 equals to 2 to the power of a. Work out the value of a. So whenever we have similar bases existing alone on each side of the equal to sign, we can put the powers equal to each other and then solve for the unknown value. So we'll put 5a plus 1 equals to a. 5a minus a equals to negative 1. That's 4 equals to negative 1. A is negative 1 over 4. That is your answer. Part B says 3 to the power of negative 7 divided by 3 to the power of c equals to 3 to the power of negative 3, bracket close, then 2c in the power. Work out the value of c. We're again applying rules of indices over here. Whenever we have similar bases being divided, we subtract the powers. It's going to be 3 to the power of negative 7 minus c. The base remains the same. What's changing is the power. And whenever there's a power inside the bracket and outside the bracket, we multiply them. So negative 3 times 2c. So that's 3 to the power of negative 7 minus c equals to 3 to the power of negative 6c. Similar bases existing alone on each side of the equal to sign, so we put the powers equal to each other. So bring the c to the other side. So negative 6c plus c over here. Negative 7 equals to negative 5c. Negative 7 divided by negative 5. So c is 7 over 5. That is your answer. Question 8 says k is a positive integer. Prove that 4k times k plus 8 minus 4k plus 9 times k minus 1 is a multiple of 9. So for this, what we will do is we will first expand the brackets. So that's going to be 4k square plus 32k. Then expand these two brackets. 4k times k is 4k square. 4k times 1 is negative 4k. 9 times k is 9k, and 9 times negative 1 is negative 9. Select the like terms in the bracket. So 4k square plus 32k minus 4k square plus 5k minus 9. 4k square plus 32k minus 4k square minus 5k plus 9. We distributed the negative sign with all of the terms in the bracket. 4k square minus 4k square is 0. 32k minus 5k is going to be 27k. And then plus 9. If you take 9 common, that's 9 bracket 3k plus 1. Since 9 is a common factor between 27k and 9, that goes to show that this is a multiple of 9. So that's your answer. Question 9 says f of x equals to x squared plus px, where x is less than equal to 1. It is also equal to 2p minus 1 over 2x, where x is greater than 1. A sketch of y equals to f of x is shown. We have to work out the value of p. So first we'll substitute x equals to 1 in the first equation. So f of 1 is going to be 1 squared plus p times 1. That gives us 1 plus p. Now for the second one, we again put x equals to 1. So that's going to be 2p minus 1 over 2 times 1. That gives us 2p minus 1 over 2. Now we put both the equations equal to each other. So that's 1 plus p equals to 2p minus 1 over 2. Collect the like terms on each side. 1 plus 1 over 2 equals to 2p minus p. That's 3 over 2 equals to p. That's your answer. It was quite straightforward. They had told us that we had a piecewise function where in one part x was less than equal to 1 and in the other it was greater than 1. So we put x equals to 1 in both the equations, find the answer for that, and then put them equal to each other, because if you look at it, they have this common point. So at this point, x is 1 for both the functions. So when you put them equal to each other, we get the value of p, which is 3 over 2. Question 10 says these are the first 4 terms of a quadratic sequence: -1, 11, 31, and 59. Work out an expression for the nth term, giving your answer in the form of an squared plus b, where a and b are constants. So first, let's find the common difference. Between -1 and 11, the difference is 12. Between 31 and 11, the difference is 20. And between 59 and 31, the difference is 28. Between these two, it's 8, and again, it's 8. So the common difference is 8. So for the coefficient of n square, we divide common difference by 2. That gives us 4. So a is 4. Now what we will do is we will create an equation using 4n square. First, let's write the original sequence. That's -1, 11, 31, and 59. Now, when we have 4n squared as the nth term, that's going to be 4, then it's going to be 16, then it's going to be 36, and then 64. We just substitute n with 1, 2, 3, and 4. Next step is to find the difference of these. So we're doing 7 minus 4n squared. So that's going to give us -5, -5, -5, and again -5. So that means our nth term is 4n squared minus 5. And that is your final answer. So first step is to find the common difference. Then you divide the common difference by 2, and that number becomes your coefficient of n squared. Then you make a table with the original sequence, and then using the nth term that you have, and create another sequence. Then you subtract the new sequence from the old one, and whatever difference you get, you add that to the nth term. In case it wasn't a common number like we have for -5 and it was a sequence of other numbers, then you find the nth term for that sequence and that gets added to your 4n squared. So it would vary depending on what your equation is. Question 11 says simplify fully 3 over 4w plus 1 over 6w. So we're adding fractions with unlike denominators. So first we have to make the denominator equal. We can multiply the first fraction by 6 and the second fraction by 4. Both the numerator and denominator will get multiplied by 6 and 4. That's 18 over 24w plus 4 over 24w. Denominator becomes 24w and numerator is 18 plus 4, and that's 22. We can simplify that because 22 and 24 both come in the 2 times table. That's 11 over 12w. That's your answer. Then part B says factorize fully x minus 1 to the power of 9 plus x minus 1 to the power of 8 times x plus 4. We can see that x minus 1 is common between this and this. So we take x minus 1 to the power of 8 common, reason being that x minus 1 to the power of 8 is smaller than x minus 1 to the power of 9. So we take the greatest common factor common, which is this, and then we're left with x minus 1 plus x plus 4 in the bracket. So x minus 1 to the power of 8 times x plus x is 2x minus 1 plus 4 is plus 3. So that's your answer. Third part says that factorize fully 8y squared minus 50. Again, let's see if there's a greatest common factor common between 8 and 50. And that's 2. 2 bracket 4y squared minus 25. Now, if you notice, 4y squared minus 25 is difference of perfect squares. We have two perfect squares being subtracted. So that can be rewritten as 2y plus 5 times 2y minus 5. Difference of perfect squares says that if we have a square minus b square, that can be rewritten as a plus b times a minus b. So 4y square is basically 2y whole square and 25 is 5 whole square. So that's why it's 2y plus 5 and 2y minus 5. So 2 times 2y plus 5 times 2y minus 5 is your answer. Next question says that circle the matrix that represents an enlargement scale factor 3 center O. So that is going to be this one. The reason being that your identity matrix is 1, 0, 0, 1. So when you times it by 3, it becomes 3, 0, 0, 3. Then part B says OABC is the unit square, where O is 0, 0, A is 1, 0, B is 1, 1, and C is 0, 1. K is the transformation represented by 1, 0, 0, negative 1, and L is the transformation represented by 0, 1, negative 1, 0. OABC is mapped to OA dash B dash C dash under a combined transformation of K followed by L. Work out the coordinates of A dash, B dash, and C dash. Find the combined transformation of K followed by L. What we'll do is we'll multiply L with K. So that means we'll write 0, 1, negative 1, 0 times 1, 0, 0, negative 1. So as we know, when you're multiplying matrices, first row with the first column, then first row with the second column, and then we repeat the same with the second row. So first is going to be 0 times 1 plus 1 times 0, then 0 times 0, and then 1 times negative 1. Then negative 1 times 1 plus 0 times 0, and then again negative 1 times 0 plus 0 times negative 1. That's going to give us 0, negative 1, and then again negative 1, and then 0. Now, we're going to multiply this matrix with the coordinates to find the coordinates for A, B, and C. So 0, negative 1, 0. It's multiplied with 0, 0 over here, 1, 0, 1, 1, and 0, 1. So same steps as we did before, row times column. 0 times 0 is 0, plus negative 1 times 0 is 0. Then 0 times 1, 0, plus negative 1 times 0, again 0. 0 times 1, 0. Negative 1 times 1 is negative 1. So negative 1 comes over here. 0 times 0 plus negative 1 times 1. That's again negative 1. Now, negative 1 times 0 is 0. Again 0, so that's again 0. This is negative 1 times 1, negative 1. So plus 0, so negative 1. Negative 1 times 1, negative 1 plus 0. Negative 1 times 0 plus 0 times 1, that's 0. So coordinates of A are 0, negative 1, B are negative 1, negative 1, and C are negative 1, 0. These are the coordinates. Question 13 says rearrange x equals to 3k squared over 5k squared minus 2 to make k the subject. Very simple. We cross multiply first to get rid of the fraction. So k times 5k squared minus 2 equals to 3k squared. Expand the bracket. 5k squared x minus 2x equals to 3k squared. Since they want k to be the subject, so we collect all of the terms with k on one side. So 5k squared x minus 3k squared equals to 2x. Take k squared common. So 5x minus 3 equals to 2x. K squared equals to 2x over 5x minus 3. And to make k the subject, we will take the square root. So 2x over 5x minus 3 gets square rooted. And it will be plus minus because they haven't specified whether k is positive or negative. So we'll write both plus minus outside the root. Question 14 says all lengths shown are in centimeters. Use Pythagoras theorem to show that 4w squared minus 8w minus 21 equals to 0. So according to Pythagoras, your hypotenuse square equals to the sum of the square of the other two lengths. So 3w plus 2, which is your hypotenuse, square equals to w squared plus 2w plus 5 whole square. Expand the bracket. 9w squared plus 12w plus 4 equals to w squared plus 4w squared plus 20w plus 25. This is your expansion. Now, bring all of the terms on one side. So 9w squared minus 4w squared minus w squared, then plus 2w minus 20w, then plus 4 minus 25 equals to 0. So that's 4w squared minus 8w minus 21 equals to 0 as shown in the question. Part B says work out the size of angle x. So for the size of angle x, we need to find w first. So we'll use our quadratic version. 4w squared minus 8w minus 21 equals to 0. Let's factorize this. So 4 times 21 is 84. Factors of 84 are 14 and 6. There are several factors for 84, but the pair that I'm going to choose is 14 and 6. It's because 14 minus 6 is 8, and that's the middle term which we're trying to replace. So 4w squared minus 14w plus 6w minus 21 equals to 0. Now we're going to split the equation into two groups and factor those two groups separately. The first two terms make one group and the last two terms make another group. So between 4w squared and 14w, we have 2w common. So 2w minus 7. Between 6w and negative 21, we have 3 common. So again, 2w minus 7 in the bracket. We take 2w minus 7 common and 2w plus 3 comes in the bracket. So one value of w is 7 over 2 and the other is negative 3 over 2. Now w was one of the lengths of the triangle, so obviously the negative 1 is not applicable. So based on the measurements that were given, this was our triangle. This is 7 over 2, which is w. This is going to be 2 times 7 over 2 plus 5. And this is 3 times 7 over 2 plus 2. So this one becomes 7 plus 5, which is 12. So this is angle x and this is a right angle triangle. So we can use tangent. Tan of x equals to opposite, which is 7 over 2, divided by 12. X equals to tan inverse of 7 over 2 divided by 12. And that gives us 16.26, which we can round to 16.3 degrees. So that's your angle x. Question 15 says, for a curve y equals to f of x, dy by dx equals to 1 minus 9 over x squared. Show that the curve has a turning point where x is 3. So the turning point, what we do is we put dy by dx equal to 0. Because the turning point has a gradient of 0. So 0 equals to 1 minus 9 over x squared. Take the 9 over x squared to the other side. 9 equals to x squared. X equals to root of 9, and that is plus minus 3. So since one value is positive 3, so that shows that the turning point is at x equals to 3. Then it says, use d squared y over dx squared to work out the nature of the turning point. You must show your working. So your dy by dx is 1 minus 9 over x squared. So let's rewrite this as 1 minus 9 times x to the power of negative 2. I'm bringing the x squared in the numerator, so that makes the power negative. Now we differentiate this again. So that's going to give me negative 2 times negative 9 times x to the power of negative 2 minus 1, which is 18 times x to the power of negative 3, and that's 18 over x cubed. For the nature of turning points, what we'll do is we'll substitute x equals to 3 and negative 3 in this equation. So at x equals to 3, d squared y over dx squared is 18 over 3 cube. That's going to give us a positive value, which is 2 over 3. So this point is minimum. Then at x equals to negative 3, d squared y over dx squared is going to be 18 over negative 3 cube. That's going to give us negative 2 over 3. So that is a maximum point. So if they're just referring to that point, then that's a minimum point. But if they're talking about both the turning points, then it's maximum and minimum. Minimum for x equals to 3, maximum for x equals to negative 3. Question 16 says A, B, C, and D are points on a circle where EBF is a tangent. We have to work out the value of x. To work out the value of x, what I'll do first is I'll find this angle. This is a cyclic quadrilateral because all 4 vertices of the quadrilateral are touching the circumference, which means opposite angles add up to 180. So BCD is going to be 180 minus 4x plus 15, and that's going to give us 195 minus 4x. Now, if this is 195 minus 4x, next circle theorem that I'm going to use is the alternate segment theorem. According to the alternate segment theorem, if all 3 vertices of the triangle inside the circle are touching the circumference, that means this angle will be the same as this. This angle will be the same as this. So this is also 1 over 2x plus 60. So what we can do is we can either find the sum of angles for the straight line or find the sum of angles for the triangle. Either way, the equation is going to be the same and it's going to give you the correct answer. So let's make the equation. That's going to be 180 equals to 195 minus 4x plus x plus 20 and then plus half x plus 60. Combine all the like terms, so 180 equals to 275. And then minus 4x plus x is negative 3x, and 0.5 minus 3x is negative 2.5x. So then we'll do 180 minus 275 divided by negative 2.5. And that gives us 38. So x equals to 38 degrees. Question 17 says solve 2a plus 4b plus c equals to 12 and 3a minus b plus 2c equals to negative 2 and a minus 5b minus 3c equals to 6. So we have a simultaneous equation with three equations. Do not use trial and improvement. You must show your working. Because first thing what I'm going to do is in the first equation, I'm going to make c the subject. So that's going to give me 12 minus 2a minus 4b. Now I'm going to substitute this in the second equation. So c will get replaced by this. So 3a minus b plus 2 times 12 minus 2a minus 4b equals to negative 2. Then I'm going to do the same with the third equation. And this way we'll have two equations with just the variable a and b. And we can solve those to find their value. And then we can substitute those in this equation to find the value of c. So 3a minus b plus 24 minus 4a minus 8b equals to negative 2. So 3a minus 4a is negative a, negative b minus 8b is negative 9b, and then negative 2 minus 24 over here. So that's negative a minus 9b equals to negative 26. That's the first equation. Then a minus 5b minus 3 again times 12 minus 2a minus 4b equals to 6. So that's a minus 5b minus 36 plus 6a plus 12b equals to 6. A plus 6a is 7a, 12b minus 5b plus 7b, and then 6 plus 36 over here, which is going to be 42. We can divide all of them by 7, so that's going to be a plus b equals to 6. Now, we can solve these two equations simultaneously. So we can say b equals to 6 minus a, and then we can substitute this in this one. So negative a minus 9 times 6 minus a equals to negative 26. That's going to be negative a minus 54 plus 9a equals to negative 26. So that's 8a equals to negative 26 plus 54, which gives us 28, and a is 28 over 8, which is 3.5. So b is going to be 6 minus 3.5, which is going to be 2.5, and c is going to be 12 minus 2 times 3.5, and then minus 4 times 2.5, which gives us negative 5. So a is 3.5, b is 2.5, c is negative 5. These are your answers. For question 18, it says ABCDEF is a triangular prism. ABCD is a rectangle and angle BCF is 90 degrees. AB is 14 centimeters and BC is 8 centimeters, with CF being 6 centimeters. M is the midpoint of EF. Work out the size of the angle BMD. So BMD. Let's connect these first. And this is the angle. So we can see that we have 6 over here, 8 over here, 14 over here. This is also going to be 6, this is also going to be 14, and this is also going to be 8. To work out this angle, first we will find the length of DB. The base is a rectangle, so that means this is a 90 degree. So we can use Pythagoras to find DB. DB squared equals to 8 squared plus 14 squared, which is going to give us 260. So DB equals to root of 260. So this is root of 260. Then we know that M is the midpoint. So if this entire length is 14, EM is 7 and MF is also 7. So EDM is also a right angle triangle. So we can use this to find the length of MD. Again, Pythagoras. MD squared equals to 6 squared plus 7 squared. MD would equal to root of 36 plus 49. And that gives us root of 85. So we have this now. Now we need MB. So for MB, this is also a rectangle. So if we find BF, then we can say this is a right angle triangle with 7 over here, and then we can find BM. So for BF squared is 6 squared plus 8 squared. BF is going to be root of 36 plus 64, which gives us 10. So if this is 10, then we can find MB, where MB squared is 7 squared plus 10 squared. MB is root of 149. So this is 149. Remove this 14 so that you don't get confused. So now we have all three lengths. And when we have all three lengths in a non-right angle triangle, we can use the cosine rule to find a missing angle. So this is our triangle MDB. So this was root of 85. This was root of 260, and this was root of 149. This is the angle that we have to find. So cos of M is going to be root 85 squared plus root 149 squared minus root 260 squared divided by 2 times root 85 times root 149. That's going to give us negative 0.115515. And I'm going to take cos inverse of this. And that gives me the angle of 96.6 degrees, correct to one decimal place. So that is your answer. Question 19 says f of x equals to 4x cubed minus 7 and g of x is 6x plus 8. We have to work out the values of x for which f of 2x equals to g of fx. So we have to find this composite function first and then put equal to f of 2x. So first f of 2x is going to be 4 times 2x cubed minus 7. As you can see, we just replace x with 2x. That's 4 times 8x cubed minus 7, which is 32x cubed minus 7. G of fx means that we're going to replace x in g of x with fx. So 6 times 4x cubed minus 7 plus 8. Wherever there was x, we wrote f of x. So 24x cubed minus 42 plus 8, which is 24x cubed minus 34. Now put both of them equal to each other. Collect the like terms on each side. 32 minus 24 is going to be 8x cubed, and 7 minus 34 is negative 27. X cubed is negative 27 over 8. We take the cube root on both sides, and that's negative 3 over 2, which is your value of x. Question 20 says, here's a sketch of the curve with the equation y equals to 4 plus 2x minus x squared. The tangent to the curve at the turning point B is shown. The normal to the curve at U meets the tangent at R. Work out the x coordinate of R. So for the y coordinate, it's going to be 5 because it's a straight line. So what we're going to do over here is, we know that y equals to 4 plus 2x minus x squared. P is the turning point of this curve, and at this curve, we have a straight horizontal line that's passing through P and R. So if we differentiate this, dy by dx of this curve, that's going to be 2 minus 2x. So now that we have the gradient of the curve, point Q will also have the same equation for the gradient because it lies on the curve. So to find the gradient at Q, what we will do is we'll substitute x with 3. So 2 minus 2 times 3, and that's going to be negative 4. So the gradient at Q is negative 4. And the question said that the normal to the curve at Q meets the tangent at R. So this is your normal, which means this tangent over at Q is at right angle with the normal at Q. So if we have the gradient of this line, which is negative 4, which means gradient of this line is going to be m1 times m2 equal to negative 1. Because when you have two perpendicular lines, the product of the gradients always equals to negative 1. So m2 is going to be negative 1 divided by negative 4, which is positive 1 over 4. So gradient of this line is positive 1 over 4. This is m1, this is m2. Now we can create an equation for QR. So QR equation is going to be y minus 1 equals to 1 over 4 times x minus 3. I'm going to use the point slope form to create this equation. So 4y minus 4 we cross multiply equals to x minus 3. 4y equals to x minus 3 plus 4. 4y is x plus 1. So y equals to x over 4 plus 1 over 4. The y value of r is 5, so we replace y with 5 because r lies on this line. So we can easily use this information to find the x coordinate. So x over 4 plus 1 over 4. 5 times 4 is 20 equals to x plus 1. And then 20 minus 1 is x, which is 90. So the x coordinate of r is 90. Question 21a says theta is an angle between 270 and 360. Cos theta equals to 1 over 5k. And tan theta is negative 3k, where k is a positive constant. We have to work out the value of theta. So for this, we can use the identity that tan theta equals to sine theta over cos theta. Because otherwise, we cannot solve these two trigonometric functions. We don't have any other information. We don't know what k is. There is no other identity that we can use. So the best way is to use tan theta equals to sine theta over cos theta. Tan theta is negative 3k. Sine theta is something we don't know. But cos theta is 1 over 5k. Cross multiply negative 3k times 1 over 5k. And that gives us the value for sine theta, which is negative 3 over 5. So if sine theta is negative 3 over 5, we can easily just plug this in the calculator to find the value of theta, which is going to be negative 36.9. Now sine is negative in the third quadrant and the fourth quadrant, which means one angle is going to be 36.9 plus 180, and the other one is going to be 360 minus 36.9. So this one is going to be 216.9 degrees, and the other one is 360 minus 36.9. That's 323.1 degrees. Our angle is between 270 and 360, so that means 323.1 is our answer. The other angle is not applicable because it doesn't fall in the given range. Then the second part says that work out the value of x between 0 and 360 for which 8 cos square x minus cos x is equal to 0. Very simple. We factorize this. We're going to take cos x common. And that's going to leave us with 8 cos x minus 1 in the bracket. Cos x equals to 0. And 8 cos x minus 1 also equals to 0. So x is cos inverse of 0, which gives us the value of 90 and 270, because that's where cos is equal to 0. Now over here, cos x equals to 1 over 8. X equals to cos inverse of 1 over 8, which equals to 82.82 degrees. Now cos is positive in the first quadrant and the last one. So for the second value of cos, we will do x equals to 360 minus 82.82, which will give us 277.18. So our answers are going to be 90, 270, 82.82, and 277.18 degrees. And with that, we're done with the paper 2 for AQA Level 2 Further Maths. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you like this video, please leave a thumbs up and subscribe to this video and share it with your friends.